So today we will discuss about how to design an algorithm given a problem. So before we get to discuss about how to write an algorithm, what is an algorithm?
Algorithm is nothing but it is a set of instructions to solve a given problem.
So if you are given with problem, say for example, if I want to find sum of two numbers, that is a problem. So you cannot directly find sum of two numbers. So you have to follow sequence of steps before finding the result. So this sequence of steps is called as algorithm. So it is essential you need to write the algorithm before you actually code the problem. So what is the various ways of solving a problem? One is writing the algorithm. What are the other ways you can solve the problem? Pseudocode. You can write the pseudocode or you can draw a flowchart. So these are the various methods for solving the problem. So algorithm is we write in our English. Normal English is natural language. So flowchart is a graphical or pictorial representation. So what about pseudocode?
Pseudocode is like keywords.
So algorithm you write in user perspective. You will write in such a way that user can easily understand, whereas the pseudocode is written in such a way that programmer can understand. So keywords will be included in pseudocode, whereas in case of algorithm the keywords will not be included. So how this algorithm has to be written? For example, if I want to find sum of 100 numbers, say if I write 100 steps for finding the final result, will that algorithm look good?
No.
No. So the finite number of steps. The algorithm should terminate with finite number of steps. So for a given problem, how many algorithms can we design? Is it possible that we shall write only one algorithm?
No, many number of algorithms.
So based on everyone's perspective, for a given problem, you can write more than one algorithm. So there are various steps that has to be followed in analyzing an algorithm. So, for example, this person, Sarvesh is writing an algorithm to solve a particular problem that may take 10 seconds, whereas the algorithm written by Sherwin may take 20 seconds. So, the time that the algorithm takes to produce the final result may vary from individual to individual. So, of all the algorithms, we have to find the efficient one. So, for finding the efficient algorithm, we have to perform certain analysis. So, someone can explain the fundamentals in solving the problem.
First, let me explain the analyzing, how we can analyze an algorithm. Analyzing an algorithm basically divided into major two types, like time complexity and space complexity. Time complexity is all about indicating how fast the algorithm can be run or written. It's known as a time complexity. In space complexity, it defines how much the space that can be taken for an algorithm to be run. That is known as a space efficiency. Or space complexity. In time complexity, there are major three types. The major three types are average case, worst case, and the best case. In best case, the best case is denoted as a omega. In average case, the average case is denoted as a theta. In worst case, the notation is noted as a big O. Let's see an example for solving a problem. Let's take an example like a woman. A woman in a home cooking for a person or a guest in her home. In a problem A, let's take a woman. Woman in that house, she only having two vessels. But in a case B, let's take a woman in a house having a one big vessel. She is cooking for nearly a 15 persons or a 5 persons. Let's take an A. In A, she has two vessels, right? Two small vessels. Cooking for 15 members and two small vessels will take a more number of time, right? Like we should cook in a one vessel, and we need to convert or change that particular things into another vessels, and we want to rewash it and want to cook again in that particular vessel, because it will take a more number of time to cook for the particular 15 members, whereas in B, she have a big vessel. In the big vessel, she can cook for the particular 15 members in a one time. Like she will add everything in the particular one vessel. She has no need to change the particular vessel. Like in this example, let us taken the woman with A and the woman with B. In a woman with A having two vessels, in a woman with B having one vessel. Analyzing this problem, we get the solution as the woman with the B will have a less complexity, and she will cook the food for the 15 members in a more faster time.
So as she have said, here the problem is to cook for the guest.
Yes, ma'am.
So the number of guests may vary. The number of guests may vary from 1 person, 2 person to n number of person. Let us assume 2 guests are arriving to your house. So if you want to cook for 2 guests with limited amount of vessel, the time taken will be. So for 2 vessels, if you 2 persons you are having 2 vessels, time taken will be less. So let us assume the number of guests arriving at your house is around 50. So you are having only 2 vessels at the house, your house. So the time taken will be more. So when space is less, your vessel is nothing but the space. When space is less, the time taken is more. On the other hand, if you are utilizing more vessel for cooking, space is more, the time is less. So here there is when there is a compromise between time and space. So if time is increased, space is reduced, or if space is increased, time is reduced. So this compromising is called as time-space trade-off.